y2 minus y1, but do you remember what did we notice from that? Like if the first difference was constant, that means what kind of function I have? Linear. And if the second difference was constant, then I had quadratic. Okay? So we're going to have to test this. Let's see what kind of function do I have. Do I have a linear? Do I have quadratic? Or neither? Okay? So to do the first difference, remember that you have to do y2 minus y1. You guys, so 4 take away 2. Yeah? 4 take away 2 is 2. 8 take 16 take away 8. 32 take away 16. 64 take away 32. 128 take away 64. 256 take away 128. 512 take away 256. 1024 take away 512. And I can't do any more, right? So the last one is going to be. Is it linear? Is my first difference constant? No. So it's not linear. Good. Now we're going to have to test the second difference. Right? So second difference tells me I take my first difference and I subtract them. Yeah? So I take 4, take away 2. 2. 8 take away 4. 4. 16 take away 8. 32 take away 16 is 16. 64 take away 32 is 32. 128 take away 64 is 64. 256 minus 128 is 128. And 512 minus 256 is 256. Is my second difference constant? So it is not quadratic either, right? So it's not linear and it's not quadratic. Do you see anything special about the first and second difference? Same as what? Same as each other, right? Yeah. Is it the same as your y values? 2, 2, 2. 4, 4, 4. 8, 8, 8. 16, 16, 16. So there's a pattern here, right? You guys see that? Even if I do the third difference, guess what's going to be? It's going to be exactly the same. To the fourth, it's going to be the same. So this is what kind of like, okay, there's something here that is indicating that it is not a polynomial function. Okay? Polynomial means it's not to the power of 2, or to the power of 3, or to the power of 1. It's not that. It's not x to the power of a number. Okay? So here's where we're going to start testing what we call the ratio. What does the word ratio mean? If I'm talking about multiplication, division, subtraction, addition, what does the ratio mean? Huh? So what do I do to find the ratio? Do I divide, do I multiply, do I subtract, or do I add? Divide. Okay? So right now we're going to test our ratio. Eyes on me. Right now we're going to test the ratio. Okay? So the ratio is you take your y values and you divide them. So that means you're going to do y2 divided by y1. In this case here, we were doing y2 minus y1 because it's called a difference. Right? But when it comes to the ratio, I have to do division. So I'm going to go back to my original y values, and I'm going to divide them. So I'm going to go 4 divided by 2. You see that I went back to the y values. I didn't use the first difference, and I didn't use the second difference. I went back to the y values. So 4 divided by 2 is 2. 8 divided by 4 is 16 divided by 8. 32 divided by 16. 64 divided by 32. So guess what? They're all 2. So in this case, I can say that my ratio is constant, right? So if your ratio is constant, then my function is going to become exponential. The word is exponential. Okay? So you've seen that at the beginning. Look at the numbers here. Can you describe the numbers for me? So can you describe 2, 4, 8, 16, 32? Can you describe how these numbers are growing? Are they growing fast? Are they going slow? Are they going fast then slow? Are they going slow then fast? Can you describe this for me? What do you see first? It's increasing fast right away? Or is it increasing slowly first and then fast later? Slowly first, right? 2, 4, 8. It's not a big difference there, right? But then when it comes to 32, 64, 128, and then right away I got to the thousands, right? So what we have here, we have a slow increase at first, but then it's a huge increase after, right? I'm doubling, but then if I double 2, it's only 4. But if I double 500, that's 1,000. You see that? I'm still doubling, but my numbers are getting bigger, faster. Okay? So let's look at this. Let's plot these. I might not be able to plot all of this. Okay? I might not be able to plot all of these numbers because I don't think I can fit 1,000 on my page, or not even 500. Okay? So let's see how we're going to use this. I think I should use a different color so it shows. So if I go up by 10, let's say, I don't know if that's going to even fit anything. 10, 20, 30, 40, 50, 60. Yeah, I might be able to do 10. So let's go up by 10. And this is right here is the number of layers. And what goes on the bottom? What goes on the bottom? Number of folds. You're gonna have to write down what the X and Y mean, right? So I have 1, 2, 3, 4, 5. I think that's way too many. So if I have one fold, so 2 is gonna be right here, where it's like close. It's like here. If I had 2 folds, I have 4 layers, 3 folds, 8, 4 folds, 16, 5 folds was 32, 6 fold, 64, and I don't think I can fit the 7 fold, but it's going to be somewhere right here. So if I'm gonna draw this, it's gonna be like this, right? we see that at the beginning we have a slow increase, right? Right here, we have a slow increase, but then we have a sharp increase later on. Okay? Now, my question to you is, if I had 0 folds, how many layers did I have? 1. So if I want to add a point here, I can add a point right here, which is at 0, it's going to be 1 fold, right? Now, if I had -1 fold, can I have a -1 fold? So if I want to go to the negatives, can I have a -1 fold? Can I have, if I rip it, would that be a -1 fold? Yeah. So how many layers do I have right now if I rip it in half? If I rip it. If I rip it, it's a -1. So how many layers do I have? Do I have a full layer? Do I have half of a layer? What do I have? Half of a layer. Okay. Now what if I took the half of a layer and I rip it again in half? What do I have of the full layer? What do I have left? So this is the full layer right here, right? It's not a third. Right? Now I have a quarter left, right? If I take that quarter and I rip it, I have 1/8. If I took the 1/8 and I rip it, I have 1/16. If I took the 1/16 and I rip it, I have 1/32, 1/32. So if I take this and I keep ripping it, right, it's gonna keep getting smaller to a point that I'm gonna get to a point where I can't rip anymore. But if I go microscopically, I'm gonna have molecules inside of there, and then I'm gonna be able to see the microscopes. Is it gonna ever disappear? No. It's never gonna get to a 0. So if I want to actually extend this, don't do that. Don't write that. But if I want to extend this, it's gonna get closer and closer to that x-axis, but it's never going to touch that x-axis. It's never going to get to that 0 value. Okay? So what you're going to see a plateau, because it is going to get smaller, but then the number is going to be very like 0.000000001. Okay? Where it's very hard to see, very hard to graph, but it's never going to reach that 0. Do you understand what I'm trying to say to you here? So that exponential function, we know it's exponential because I told you so, right? You're going to have a plateau, and then it's going to increase, and then it's going to increase rapidly. Okay? All right. So we have already talked about some of these answers, so let's kind of answer them together. So describe how the number of layers changes as the number of folds increase. So it doubles, right? When we calculated the first and second difference in the table, what did you notice? Are they constant? They're not constant, but we noticed that they are the same values as the y values, right? pattern in the table. Describe it. Can you create an equation to represent the relation? So if you look at the table, do you notice anything about the x values? So let's look at the x values. What's the x values going up by? 1. Okay. How about the y values? What's happening to them? They're double. So if I want to double something, what do I do with it? What do you multiply by? You multiply it by 2, right? So if you have something, you multiply it by 2. 2 times 2 is 4. 2 times 2 times 2, or 4 times 2 is 8, right? 8 times 2 is 16, right? So I'm multiplying by 2. Let's look at this for a second. So the first one I had was 2 times 2, right? And that gave me 4. You guys agree with that? Second one, it was 4 times 2. But I know that 4 came from the 2 times 2, right? So I have 2 times 2, and then I multiplied it by 2 to give me 8. Yes? So this is coming from this. Now, then I multiply 8 by 2. But what is 8? 8 is 2 times 2 times 2, right? So I'm taking 2 times 2 times 2, and I'm multiplying it by a 2. So what does that give me? 16. Now I take the 16, which is 2 times 2 times 2 times 2, multiplying it by another 2. Now, instead of writing this, how can I simplify this writing? What would it be? So this is going to be 2 to the power of 2. This is going to be 2 to the power of 3. This is going to be 2 to the power of 4. This is going to be 2 to the power of 5. Yeah? Now, that 2, 3, 4, and 5, they're how many folds I have. Yes? If I had 2 folds, so if I took my paper and I folded twice, I ended up with 4 layers. Right? If I took my paper and folded 3 times, I ended up with 8 layers. Do you guys understand that part? The 2 is coming from the doubling. That base of 2 is coming from the doubling. That exponent is coming from the number of folds. What if I have 15 folds? What would I write? If I folded 15 times, what would I write? 2 to the power of 15. If I had n folds, what would I write? N folds. 2 to the power of n. Right? So instead of writing this, I can come up with an equation that is like this. Y equals 2 to the power of x, right? Where x is the number of folds and y is the number of layers. I'm just going to take you quickly, I'll come back to this. I'm going to take you quickly to this. Y was my number of layers and x was my number of folds. Right? So when I write my equation, I have to stick with the same thing. X is my number of folds and y is my number of layers. So where did that 2 come from? The doubling. That 2 is because it's doubling. What happened if it was tripling? So what would change? That 2, it becomes a 3, right? Yeah? Now when we calculated the common ratio in the table, what did we do? We did y2 divided by y1. And what did we notice? That the first ratio is constant, right? What was the first ratio? And do you know why it's 2? And where do I see that 2 in my equation? Why? It's this, right? Which we call it the base. So, my base, which is this, is the same thing as my ratio that I. It's not a coincidence. It was meant to be. It is going to happen all the time. Whenever you do your ratio, if your ratio is constant, right, that ratio is going to be the base of your equation. Now, here's what I have. So we call this exponential. Okay? Exponential means you start increasing slowly and then fast. Okay? That's what the word exponential. In an exponent equation, I have this. I have y equals a base to the power of x. So we call it exponential. Okay, so this is basically a mini lesson that I'm. So we call it exponential because the exponent is the variable. And your base is a number, it's a value that is equal to the ratio. So how can you tell it's an exponential function? If your exponent is a letter. If your exponent is a letter, we say it's an exponential function. Question for you. Is this an exponential function? No, because my exponent is a number. My base is the letter. What do we call this? What kind of function is this? Quadratic, because it's an exponent too. Yeah? How about this? Is this an exponential function? Yes. My exponent is a letter. So it's exponential. What's my base here? What's the base? A half. Right? The base that I had earlier was a 2. The base could be 3. It could be 1 over 10. I don't know. The base can change. Right? But it's still exponential. Do you guys understand the difference between what we've been learning so far, which is quadratic, to the exponential right now? So the exponential right now, the exponent is the variable. Are we okay with that? So here are the 3 things that we have covered so far, either from grade 10, 11, and 12. 11, sorry, there's no 12. So in the grade 10, we learned mostly about linear functions, right? But we have already also looked at them, looked at these linear functions in grade 11. And we have said that a linear equation, how would it look like? Y equals, it's a straight line, and it's going to be y equals mx plus b, where x has an exponent of 1, right? You guys remember that? So in the table of values, what was constant for linear? The ratio for linear? The first difference. And then we said that a linear function is going to be a straight line. How about quadratic function? How would the equation look like? Y equals what? Give me the standard form. Standard form.
Y equals A plus B.
Standard form? Standard form? And I know that this is quadratic because of that's in the table of values, but if I look at this, I know it's quadratic because of degree 2, right? In the table of value, the second difference was constant. And what was the graph of it? Parabola, right? Either opening up or opening down, does not matter as long as it's a parabola shape. Now with the exponential relation, your equation is going to look like this. Y equals a number, which is your base, to the power of x, right? It's always a letter which is going to be your variable. B is going to be a number, okay? Table of values, what would be constant? The ratio. And then how would the graph look like? It's going to be a slow increase, then a fast increase, right? It could also be a fast decrease, and then a slow decrease. So it could be either increasing fast, increasing slow, and then fast, or it could be the other way around. Okay? Because we might have an increase or a decrease. It depends on my function. So what I want you to do is, I want you to look at these questions, and then you're going to decide if it's linear